Also, the space station is in a really cool orbit. It goes around the Earth 16 times in 24 hours. It's going almost 18,000 kilometers per hour. It's in a vacuum up there. And it's really interesting just to look up too. Look up the astronauts in the space station explain it the best, like what it's like to be up there moving that quickly.
Floating, not touching anything long enough, eventually you would slow down.
I mean, they keep lights going like still on Earth. They keep like lights in the International Space Station to help them kind of relate more to their circadian rhythm, but they are floating. Like when they sleep, they just get like strapped to the wall and they sleep like this. Like there's not enough gravity. Great question. So we can send rockets to the space shuttle much more easily than we can send people. So they can get food and things up there and supplies and tools.
Why can't they just set a rocket and bring them back?
Because like it's harder to keep it a safe environment for living things than it is like tools and food. So like the gravity and the air pressure and everything is just more difficult. So all good questions. You guys should look it up on YouTube. There's lots of coverage of the astronauts in the International Space Station. There's people up there, not just the two, that stay up there for like a year and they keep things running and they're always cycling in and out. You can Google it right now if you want. Like how long do astronauts stay in international? And there are people from other countries too in there.
Why don't we just go to a different planet?
All right, let's get back to this. Preparing for your test Friday. Keep in mind you can use open book and open note, and I've agreed to 80% this time. So does this?
This is always 80%.
I think it was
Let's do it right now. Okay, so do y'all think this table is exponential? Is it growth or decay? And we need to write an equation. So yeah, when I look, it is definitely going up. What's the pattern?
Multiply by 3.
Multiply by 3 every time.
Sounds so smart. Yeah.
When the pattern is difficult to identify, you use a ratio. And so the ratio would be 21 divided by 7. That is 3. You can do 21 over 7, or you can do 63 over 21. That's also 3. Or you can do 189 over 63. That's also 3. So it's being multiplied 3 every time. The exponential equation we're writing is a times b to the x. So far we know it's a times 3 to the x. Does anybody know what a is? 7. 7 times 3 to the x. How'd you know it was 7?
Because 7 is equal to 0.
Yes. So I want to remind you that the y-intercept is the a value in this function. Alright, so I'm actually going to go through the Chapter 6 online review part 2 with you today. It's due Friday. Let's get it done today. If you are done, I want you to do Skills Trainer. That's the 3 lines in the top right-hand side. And look specifically for exponential functions. So I'm thinking about giving extra credit for that Skills Trainer. Let's go to Big Ideas, Chapter 6, Review Part 2. You finished it. Yeah, I'm updating grades today. So. We're going to Part 2. paper.
Wait, do what?
If you want to use it for your test Friday, do it on paper.
Do what on paper?
The assignment today, which is online.
That's out of my notebook.
You need a borrow this paper?
Can you send back part 1 for me? I probably got a bad grade on it.
That doesn't mean you can read it.
Let's see how you do the part 2.
I'm sure it's very fun.
You said, let's see how I do a part 2.
Yeah.
I'm gonna do it. I'm gonna.
I'm down the graph picture. I'm probably gonna go in order.
We think that you got five.
What did we do yesterday?
Just use online assignment.
Some issues with the Bible.
Wow, really, Noah?
Yeah. You didn't do that already on it? You just,
Oh, I just don't like to.
Same. Same. Yeah, same. I wasn't here.
David.
Nothing.
All right, number 1. Write a function in terms of t that represents the situation.
I got it right.
Okay, increases indicates growth. How is this going to help you if you're going to use open notes though? I'm concerned about that. You have to do it on paper. The problems are in your textbook. These are the chapter 6. Oh, you don't have a book.
I have a book.
Can we use a big idea?
Does anybody want a textbook right now? And you can write on it and rip it out.
Is it the same question?
But we can.
For order.
What you want one?
I want to pass my test, Riley, not come into you.
They stop on.
I'm walking in here.
You don't have Wow.
Permission to rip out the review here, or just keep it in here. Use this. I'm gonna pass these out during the test Friday, so you can use anything in here, chapter 6, during the test Friday. If you want to write in here and put your name on it, we'll make sure you get this one.
That's what page is it?
Look in the bottom to find chapter 6 and go to the review. Who else wants one? They're over there if you change your mind.
Page
What's it? Chapter 6. Page 541.
Riley, stop harassing me.
Yeah.
Page 541. I can work it out. Why?
So this is number 25. If you want to circle it. You can rip it out or you can just keep it. Keep that book, or I can just put your name on that book and you keep using that book.
How many questions are we doing on this today?
It's probably easier for you at this point to look what it is for me. I'm doing this till the end of it.
Oh, so we're doing all the questions.
Yeah, and then we're gonna go to the skills trainer after that. Alright, so for growth, I'm gonna actually put it here. It's y equals a times 1 plus the rate raised to time. And unless it says compounded weekly or compounded monthly like the credit card project, it's just a regular rate there. So I would put the $2,000 for the antique vase, put 1 plus, and then this 4.5% needs to be converted. I have to move the decimal 2 places to the left. So it's 0.045. That's number 25. So if you're looking in your book, that's number 25. I think, has anyone tried typing that in just like that yet? I think you have to put the plus together. You put it with the plus and it marked it, right? Yeah, look at this. Okay. I think to get it right, you actually have to combine the 1 and the 0.045. So let's look at how different that looks. It would be 2,000, 1.045 T. And sometimes you'll be presented a question like this and they'll say, what is the growth rate? And students will say 1.045 and really it's only increasing 4.5%. You got it right that time?
What do you have to do first?
Yeah.
You got this one right. Yes. Did you type y equals? You don't need to. Did you type y equals? There it is. Yeah. Just type it in. Out. Is this part 2 or part 1? This is part 2. Next one. Way different in this situation. The value is decreasing. So that means instead of a plus sign here, we put a minus sign. So it's 1 minus, and I have to remember to move the decimal and 11.2 to the T. So Noah, are you going to type it in just like this? Or do you want to hit a calculator and actually do 1 minus? There should be a calculator right there in Big Ideas. So it's 850.888 to the T. Notice that the base is less than 1. That is a descriptor of decay instead of growth when the base is less than 1. So the value of the phone goes down each year, and you guys know that. You guys know values of phones go down. Maybe an antique phone value might go up because it gets older and older. James, was that 26? The smartphone? It actually, you guys, with the textbook, every answer is in the back of the book. Every single answer. I'm not saying copy them, but you could at least use it to check. Right. All right, number 3. Determine whether we see growth or decay or neither. So this is just like Bower. I'm going to use fractions or ratios to look for a pattern. I'm going to do 6 over 3, 12 over 6, 24 over 12. Do they all equal the same thing? Yes, so this is exponential growth. It's being multiplied 2 every time. You got that? Marianne? Yeah. What number is that in the book? Looks like 27. Yeah. Explain your reasoning. There are constant ratios, fractions. I would say b equals 2 here. The base would be 2. Because when I do the ratios, it helps me see what's being multiplied every time. It's being doubled. You guys gonna do okay if that's a test question?
Nope.
I'm gonna do this exact problem and I'm gonna pick a different base. Maybe I'll go 4, 8, 16, 32.
Is this work too?
Yes.
Okay? Or maybe it's gonna say 5, 10, 20, 40. Okay? Can you see a pattern if you're presented with something very similar?
Maybe.
Let's try another one. All right, are we seeing growth, decay, or neither? And what is the pattern? Number 4. Number 28 in the book. Oh, wait. This is the 3rd one in this class period where you're asked to look for a pattern. Yes. This one's decay? Yes, because the numbers are getting smaller. Can you identify the decay rate, James? If I asked you about the rate. Okay, let me look. I don't even know. I'm going with decay. The numbers are going down. And I'm going to set up ratios to find the rate. So 108 over 162, 72 over 108. Well, 48 over 4 is 12. I messed that up. $48 over 72. I don't know. That reduces to 2/3. So, yep. Decay. So it's 2/3, or maybe you use the calculator and got 0.167.
What is the candidate desert?
Yes, for the test that we're on. The fraction's way better. Logan, did you get 0.167? Yeah. And did you use that handheld calculator or the one in Big Ideas? Did anybody do it on the Big Ideas calculator? And did it give you a fraction out?
No,
Like,
it means 0.6.
does it have a fraction button? So if you put this in the fraction button, I think it'll pop out the fraction answer.
Okay.
I'm curious. Alright, I'll move on. Oh, I don't want this one in here. You don't have to identify rate of change here. Is it do they accept 25% here on number 5?
Yeah.
They do? That's lucky. Alright, I'm gonna pick exponential growth because the base is more than 1. So I know that's gonna go up. James, is this 29 in the book? No. 29. And then the rate would be just 25%. You don't put the 1 in there. It's growing 25%. You have to think about what in the rate spot.
But like once we're done with this whole thing, we can move that.
I'm just gonna go already. So, Neil, what'd you get for your growth rate on it?
I got exponential. What for the top I got exponential growth, and for the bottom I got 6%, but I was
6 came out rough. There's an issue with that 8, that's why. Sure, I have 48. Try 48. What about 0.48? %? They're wrong. What's the answer? 59.
Your Chinese one.
How do we get on?
Yeah, I already submitted.
You, yeah. Where'd you look at?
Oh, after I used golf.
We're the same age. Golf AI.
Golf. Almost.
Alright, so if there's a number up here in the T spot, that changes the rate's not as obvious. So on your test, I will not put a number up there and ask you what the rate is. That's compounded 8 times per year, or 8 times per time period. Let's just move on. As long as you know it's growth, you're good to go. So just answer this one, growth or decay. You don't have to do the rate of change. Yep, decay, because you don't have to. Just say growth or decay. Decay.
So Miss, would you go back and change it so we got 100 on it, but in the ideas it says we got it off because of that?
As long as you get higher than 75%, you'll get full credit.
Oh, okay.
You don't have to get it. All right, here's a full comprehensive question with multiple choice and everything. I'd like for everyone to try to write the equation before I do. $1,500. That's your initial amount. It loses, means we use a minus sign. 14%. And the exponent is the amount of time. If you type that in, it's going to come out wrong. Why would it come out wrong? Because you have to subtract the 1. You got to subtract 1. So sometimes students will be asked, what's the decay rate? And they'll say 86%, and that's not right. You have to think backwards to what was it before the subtraction. When they see this, they say the rate's 86, but it was really 14. How much it's decreasing by each year. And then plug in and find 2 years. Get it, grab a calculator, see if you can plug in 2 and get it right.
Yeah, but this is wrong.
For this one here?
Yeah, I put that.
You put that?
I'm still calling that?
Yeah. How much is it after 2 years, right? 1,109.4. You typed it in and got it right. So then if this person wanted to sell that TV, this is how much they should sell it for. And then if you go and you look and it's $1,000, then, oh, you know, you're getting a good deal. Yeah, because we're talking about money. So yeah, 40 cents. Let me see. Okay, so for the right function, after 3 years,
Oh shoot, my call got 6 minutes left.
Yes, Abby. The one we just did. You just have to to get the growth or decay part right. Alright, now how we're going to figure out which graph it is, because I was just guessing.
This, I think, is the one
It's C.
that's at the bottom.
This is
It's like the top right.
Oh,
Top right.
oh, after 3 years? Personally, I would plug a 3 in and get a number out. Have you done that yet? If I had to figure out after 3 years, I would just use the calculator at this point. So on the first part it says T. You leave a T. And then down below where it says T, use a T. So I'm just gonna put 3 in and see how much it is. Actually no, 954. You knew which one it was?
Yeah.
So it's this one. It's swooping down. Here 3954. So our credit card graphs went up because the amount you owe over time with credit cards, if you don't pay it off right, goes up. But the value of items that are decaying, it should swoop down. We're good on this one? Next one. All right, y equals a times b to the x. If you're not talking about a word problem where something's increasing and decreasing, you don't put the 1 in. The 1 will show up in the data. So you have the initial amount. And then the constant ratio. One of your handouts goes through this. So this 400 is the A value. We know we're going to put 400 in. It's the y-intercept for the ratios. If I need to find B, I put the second y over the first y. And then I do 36 over 120. 10.8 over 36. 3.24 over 10.8. Every single one of those should come out to the same number. Test it. Test it in a calculator. Yep, there's a calculator right in the program.
Oh, 0.3.
0.3 every time.
Mm-hmm. I did this last night.
Yep, 0.3. Yep, 0.3. That's the answer for B. All of those are called the constant ratio. That's the B. B is 0.3. So our equation is 400 times 0.3 to the x power. I bet you have to use parentheses.
What's the answer again?
It's the 400, that's the first point. The 0.3, that's the base. And x is an exponent.
I just couldn't find it.
I bet you have to write parentheses around it though. So maybe.
I couldn't get a regular point in parentheses.
You got it right with 0.3.
No, I couldn't without parentheses.
Oh, miss, my Chromebook just died. Like I was mid typing the answer and it just died.
Oh,
Yeah, that's very.
this is learning. You can use that one that's plugged in my room. And what if I got plugged in from the sub? The sub tell you guys to put their Chromebooks away?
Yeah.
Did you guys plug them in?
Yeah.
Nathan took mine.
Plug them in.
400. Parentheses. 0.3. Not on the.
So actually, I am gonna be here, but I have to meet with all of the other algebra teachers.
You're not gonna be like.
So I'll be on campus and I will be in here after school. But I will be in the front office with all the teachers who do the algebra 1 EOC and the curriculum specialists talking about what you need to know. So how'd you know? How'd you guys know?
They talking about it.
I told me.
I just want all my classes today.
Finding algebra too.
Told me.
They both have their size.
No, this time it's just the teachers who have students taking the Algebra 1 state exam.
So we're taking the state.
That's the one you have to pass to graduate.
Oh, you're lying.
You got 4 years to do.
Oh, to graduate.
Oh, okay. I was about to say.
I don't even know how. I thought she meant for this year. Yeah.
I got a 2.7.
And this is very much a test question on the end of course exam. This is it. Like that. This is it. What do we do? Okay, so this.
Next time to take this out.
Yes, that's the A value. Good job.
Riley.
But then what is the B value? See, I'm going to make fractions to know for sure. And I've been calling these fractions constant ratio.
You keep winking at her. Oh, okay.
You guys, do your division. You put the second y over the first y, the third y over the second y. What will the base be? What's the base to this? Can anybody divide that? You make fractions. So just because it's not a table doesn't mean you can't use the same strategies. Those are points. You put the second one over the first one and the third one over the second one. It's 4. 4 is correct. So we got 4 to the x. Anyway, since I won't be here tomorrow, you do still have a test Friday. This is our big review. So, the handout tomorrow, you'll be able to see on the test. I'm gonna come in here and get you guys started. Bro, we're okay.
Come and get this done. I think we got it.
Everyone have to be for this
go.
one.
4?
Hold on.
Yeah. Well, it told me I was wrong. Oh, you have to put the 0.8 parentheses.
Oh, those girls went to Palm Trainer?
No.
Oh, how do you know them? Aren't they sophomore? Are they sophomore?
Volleyball.
I don't know, but they have
Bro. Oh yeah, bro. Excuse me. Excuse me.
Hey, here we go.
Here.
The value. What's an ACV? What's this about? Is that a computer?
It's a formula.
Oh, okay.
Five.
Review tonight.